Good morning, everyone. Today, we are going to learn three very important topics in mathematics that are closely connected. Pythagoras Theorem in three dimensions, 3D, and trigonometry. By the end of today's lesson, you will understand how these concepts are related and when to use each one. Part 1, Pythagoras Theorem. Let's begin with one of the most famous mathematical theorems. Imagine you have a triangle that has one angle exactly equal to 90 degrees. This is called a right-angled triangle. The theorem only works for right-angled triangles. Before learning the formula, we must know the names of the sides. There are three sides. The hypotenuse, side A, side B. The hypotenuse is always, opposite the right angle, the longest side of the triangle. This is very important. Many students make mistakes because they identify the wrong side as the hypotenuse. Always find the 90 degrees angle first. The side directly opposite that angle is the hypotenuse. Once we know the hypotenuse, we can use Pythagoras theorem. The formula is a superscript 2 plus b superscript 2 equals c superscript 2, where a equals first shorter side, b equals second shorter side, c equals hypotenuse. Notice something important. The hypotenuse is always written alone. The two shorter sides are added together. Never write c superscript 2 plus a superscript 2 equals b superscript 2 unless b is actually the hypotenuse. The hypotenuse is always by itself. What does square mean? When we square a number, we multiply it by itself. For example, 2 superscript 2 is equal to 2 times 2 equals 4. 5 superscript 2 is equal to 5 times 5 equals 25, 10 superscript 2 is equal to 10 times 10 equals 100. Similarly, square root 25 equals 5, square root 64 equals 8. The square root reverses squaring. Let's solve an example. Suppose one side is 4 centimeters. The hypotenuse is 7 centimeters. The other side is d. We start with d superscript 2 plus 4 superscript 2 equals 7 superscript 2. Now square the known numbers. 4 superscript 2 equals 16, 7 superscript 2 equals 49. So d superscript 2 plus 16 is equal to 49. Subtract 16 from both sides. D superscript 2 equals 33. Now take the square root. D equals square root 33. Using a calculator, d is almost equal to 5.74 centimeters. Always remember, length can never be negative. Even though mathematically square root 33 gives plus or minus 5.74. We only use 5.74 centimeters because distances cannot be negative. The converse of Pythagoras. The converse means we work backwards. Instead of already knowing the triangle is right-angled, we want to prove it. Suppose the sides are 6 centimeters, 8 centimeters, 10 centimeters. Calculate 6 superscript 2 plus 8 superscript 2 equals 36 plus 64 is equal to 100. Now calculate 10 superscript 2 equals 100. Since 6 superscript 2 plus 8 superscript 2 equals 10 superscript 2, the triangle must be right-angled. This is called the converse of Pythagoras theorem. Common mistakes: students often choose the wrong hypotenuse, forget to square numbers. Forget to square root at the end, forget units, round incorrectly. Always solve carefully one step at a time. Part 2, Pythagoras theorem in three dimensions. Now let's move from flat shapes into three-dimensional objects. Think of a box. A box has length, width, height. These are called the three dimensions. Suppose length equals 12 centimeters, width equal 9 centimeters, height equal 8 centimeters. We want to find the longest diagonal that passes through the inside of the box from one corner to the opposite corner. Notice something. Pythagoras still works. But we must use it twice. Step 1. Find the diagonal on the base. The bottom of the box is a rectangle. A rectangle can be divided into two right-angled triangles. The two sides are 12 centimeters, 9 centimeters. Using Pythagoras, base diagonal superscript 2 equals 12 superscript 2 plus 9 superscript 2 equals 144 plus 81 is equal to 225. Base diagonal equals square root 225 equals 15 centimeters. Now we know the diagonal across the floor is 15 centimeters. Step 2. Use that diagonal. Now imagine standing that diagonal upright. It forms another right-angled triangle. The two sides are 15 centimeters, 8 centimeters. Using Pythagoras again, diagonal superscript 2 equals 15 superscript 2 plus 8 superscript 2. Equals 225 plus 64 is equal to 289. Diagonal equals square root 289 equals 17 centimeters. Therefore, the inside diagonal of the cuboid is 17 centimeters. The shortcut formula. Instead of doing two calculations every time, mathematicians combine them into one formula. If length equals A, width equals B, height equals C, diagonal equals D, then A superscript 2 plus B superscript 2 plus C superscript 2 equals D superscript 2 or D equals square root A superscript 2 plus B superscript 2 plus C superscript 2. This formula works for every cuboid. Things to remember: a cube is just a special cuboid where length equals width equals height. The same formula still works. Always square all three dimensions. Add them. Then take one square root. Part 3, Trigonometry. Now we come to one of the most useful topics in mathematics. Trigonometry. The word trigonometry comes from tri equals 3, gon equals angles, metry equals measurement. So it literally means measurement of triangles. Like Pythagoras, basic trigonometry only works with right-angled triangles. Naming the sides, every right triangle has hypotenuse, opposite, adjacent. The hypotenuse never changes. It is opposite the right angle, longest side. The other two sides depend on which angle you are looking at. Suppose you focus on angle X. The side directly across from angle X is called opposite. The side beside angle X is called adjacent. If you choose another angle, the opposite and adjacent sides change. Only the hypotenuse stays the same. That is why you must always identify the angle first. There are three important ratios: sine, cosine, tangent. They compare different pairs of sides. Sine x equals opposite / hypotenuse, cosine x equals adjacent / hypotenuse, tangent, tan x equals opposite / adjacent. Students often remember this using SOH/CAH/TOA. SOH sine opposite hypotenuse, CAH cosine adjacent hypotenuse, TOA tangent opposite adjacent. This memory trick is used all over the world. When do we use each one? If the sides you know are opposite and hypotenuse, use sine. If they are adjacent and hypotenuse, use cosine. If they are opposite and adjacent, use tangent. What can trigonometry help us find? It helps us find missing sides, missing angles, heights of buildings, widths of rivers, distances across valleys, roof slopes, ladders, ramps. Navigation, engineering measurements, architecture, surveying, construction, aviation, computer graphics. Trigonometry is one of the most widely used topics in mathematics. Calculator tip. Before solving any trigonometry question, always check that your calculator is in DEG, degree, mode. If it is in RAD, radians, or grad, your answers will be incorrect unless the question specifically uses those units. When should you use each topic? Use Pythagoras theorem when you have a right-angled triangle. You know two side lengths. You need to find the third side. Use Pythagoras theorem in 3D when you are working with a cuboid or rectangular box. You need the diagonal through the inside of the object. You know the length, width, and height. Use trigonometry when you are working with a right-angled triangle. At least one angle, other than the right angle, is known along with a side, or you need to find a missing angle. You need to calculate missing sides or angles using sine, cosine, or tangent. Key takeaways: Pythagoras theorem only works for right-angled triangles. The hypotenuse is always the longest side and is opposite the right angle. The formula is A superscript 2 plus B superscript 2 equals C superscript 2. The converse of Pythagoras can be used to prove whether a triangle is right-angled. For a cuboid, the interior diagonal is found using D equals square root A superscript 2 plus B superscript 2 plus C superscript 2. In trigonometry, always identify the hypotenuse first, then determine the opposite and adjacent sides based on the angle you are using. Remember the three trigonometric ratios with the mnemonic: SOH, sine equals opposite slash hypotenuse, CAH, cosine equals adjacent slash hypotenuse, TOA, tan equals opposite slash adjacent. Always ensure your calculator is in degree, DG, mode unless the problem specifies another angle unit. These three topics form the foundation for many advanced areas of mathematics, physics, engineering, architecture, navigation, and computer science. Mastering them will make solving geometric problems much easier and prepare you for more advanced mathematical concepts. Subscribe to My Brainy Cave, drop a comment below, and let's keep making big ideas simple.